So I'm going to use, what was it, Theorem 17? That was the exponential rule, okay, which said anytime I take the derivative, it's either 18 or 17. Okay, so it's e to the same argument, right, times the derivative of the argument. It's really actually 18, I think, wasn't it? The first times the derivative of the second plus, remember when I have it, that's this argument, I mean this exponent right here is actually a product, right? So I've got to use the product rule when I take its derivative. Sample 5. Times the ln of x. Right, we did this, wasn't that like example B on the example 1 or number? It's like one of the first ones we've already done. Yeah. Okay. But you remember this is my rule, right? I write the thing, you know, I've got e to any exponent. I write e to that same exponent, but then I have to take the derivative of the exponent. That's all I'm doing. I think that's the 8. That's, is it 3.17? Okay. That's right. Anytime this exponent is more than x, you got to take the derivative. I missed it. Oh, because that's the power rule. We already knew that, right? Okay. Now we need to simplify this. This is e to the x times the ln of x. And so this one's 1 plus the ln of x. And you're done with that. Okay? Almost. We're done with the derivative part, right? Yes. More than x for the exponent. Then the derivative of that's 1. So it didn't matter. I mean, you can find the derivative of it, but it doesn't change your... Yes, if this was a variable raised to a number, then you use the power rule. Huh? All right. Now, remember what we started with this problem, because we had already found this derivative. This shouldn't be a new idea. Okay? But what were we trying to do? We were trying to decide if this function has any horizontal tangent lines. So what I do now, once I find the derivative, to figure out if it's got any horizontal tangent lines, I've got to set it equal to 0. I take the derivative and set it equal to 0, and that's going to tell me, do I have any equations? If I can get an x value, that means that x value, there's a horizontal tangent line right there on that curve. Okay? So, I got to solve this. How do I go about solving this? No. This is multiplied by this. No, I don't want to distribute. It's in factored form right now. When I have something in factored form, how can I solve it? I can take each factor and set it equal to 0, because it says this can be 0 or this can be 0, right? So I've already got it in factored form. Now I just need to take each factor and set it equal to 0. Anytime you have an equation in factored form, you can and it's set equal to 0, you can always take either factor separately. You want to do this one first? Okay, so what am I going to do? subtract 1, so we get the ln of x is equal to negative 1. Are you sure? Remember how to solve this? That's right. You have to exponentiate both sides. So in other words, I'm going to take each side and make it e raised to that piece. So e to the ln of x would just be x, and e to the negative 1 is just 1 over e, right? Mm-hmm. Okay. So that piece works, and that's going to give me, it is a positive number, you're exactly right. Okay, so that gives me the point 0.368. Is that good enough? All right. But if I'm looking for the point where this has a horizontal, what do I need to do with that value now? And to the original equation to find the y to go with it. The original equation. Yep. So e to the e. Or 1 over e to the 1 over e. Right. My original equation was y is equal to x to the x. So if x is 1 over e, then I got 1 over e to the 1 over e power. Right? Since he has a calculator in his hand. Works for me. So 0.7. Mine says 0.692. Okay. So there's a point where I do have a horizontal vertex. Now let's come back over here to the one Emily wanted to skip. Okay. So no, they cannot. Because you have the x in front of it. Now you can put the x back. Then you can cancel it out. So you get x to the x is equal to 0. Okay? Now, what power can you raise? I mean, what 0 to the 0 power, remember, is anything to the 0 power is 1. Anything to the 0 power is 1. Otherwise, my rule doesn't work. And so is there any way that I can get a 0 out of this? No. So this gives me a no solution piece. Okay? Good. All right. There it goes. That's all right. Next theorem. We're going to be talking about the derivative of general logs, not just LNs, but all logs. Yeah, it had the 1. Just didn't have more than 1. Okay? So, theorem 3.20. Okay. And general log looks like this, remember, log base b of x. Remember, it's got some other base besides e. That's a general log. So not an ln. But since they work the same, right? Have you remembered that all logs kind of work the same as ln's before with our other properties? Then it's probably true that these are going to work very close to the same. The derivative of the log base b of x is equal to 1 over x times the ln of b. this time the ln of the number is just the ln of the base, right? That's why it's a little different, and it goes in the denominator of the fraction. And the same thing, if you have a situation where sometimes you get a positive value and sometimes you get a negative value, and they qualify that with putting the absolute value around it so that you can go ahead and find the derivative, you still get this. What now? So it's 1 over the argument times the ln of the base. Okay? All right. So example 6, part A. So the first derivative of this, yes, log base 5 of 2x plus 1. Oh, yes, you're right. We will have to do the chain rule because this is more than just an x. Good, good. That's a way to see it. All right, so in my problem here, I do 1 over the argument, just like it is. Right? Times the ln of the base. But since my argument is more than just x, I do have to then multiply that whole thing by the derivative of the argument, which is 2. Right. Chain. Well, they go through and go ahead and pull the 2 and the ln of 5 in front for some strange reason. Because this is just a number part right here, so they pull it out in front like a coefficient. But I mean, they haven't really done anything else to it. That's it. We good? What's wrong? Except what? What's wrong? No, you don't do more to it. You just do the rule and simplify it if you can. They just, for some reason in the answer key, they pulled this out in front. Because, see, this is a number and this is a number, so they just pull it out in front so it looks like a coefficient. Not sure exactly why they bothered to do that. I'm hoping that would not, if it was a multiple choice test, that you would know that this is the same as this. Okay, that's the only thing. All right. Okay, so come on, change. The last objective.